I'm going to be talking about um, visual astronomy. Let's see, I am talking. I wonder why Kevin's icon is showing up there and he's not talking, but it doesn't matter. Um,
Yours is showing. You're good to go,
I'm good to go.
Boris.
All right. Uh, Visual astronomy, what to expect. Next slide. So, when I got excited about astronomy, it's because of pictures I would see in books and magazines and so on. In this day and age, this is probably the kind of picture you're going to see. This is a picture of the Whirlpool Galaxy, Messier 51. And it's not only aesthetically just beautiful, but it's also, this shows so many things about galaxies that are fascinating. It's really an inspiration. It's the sort of thing that pulls you into astronomy. You can see, for example, all the dark nebulae that define the spiral arms, those dark clouds of dust and gas, within which, through the action of self-gravitation, you have these star-forming regions which are showing, in the red H alpha emission. So you see the stars being formed. You see in the galactic periphery, you see the blue stars, which are the younger stars, and then as you spiral in towards the core, you see the yellow, more of the yellow color, which is the older stars. You see all this stuff, and it just shows you in one picture. You can see so much about what makes a galaxy work and how they function. It's an inspiration to get you into astronomy. You want to see this stuff for yourself through a telescope. Next slide. So, um, so this is a similar picture, a little bit older, probably. Sorry, I didn't have time today to jot down all my sources. The first picture was from a Hubble Space Telescope for sure. This one, I'm not sure what the source is. Maybe this is the state of the art in 2010. You know, next slide. Um, but when I got into astronomy, this was the state of the art. This is an image acquired on film or maybe a glass plate with chemical emulsion on it. Maybe this picture was taken with the 200-inch telescope at Palomar. And this is the thing that inspired me, an image like this. So I would go out and I would say, get me a telescope. I want to see this. Next slide. And maybe if I got a pretty decent telescope, I would be able to see something like this right here. So this is the kind of view you might get with the 20-inch that Cass has, um, the 20-inch out at, or the 22-inch out at Woodridge Farm Brewery. Uh, you might get a view like this in very dark skies. You might have to use averted vision where you're not looking directly at the axis, you're looking just a little bit off center there. You have to get your eye to be off center because if the image of the galaxy falls right into the center of your field of view, it will fall onto the so-called fovea of your retina. The fovea is where color is sensed, but the fovea is not as sensitive to low light as your peripheral vision. So for very faint objects or for very faint features, such as the spiral arms in this galaxy, you may have to avert your vision a little bit off center, and then the spiral arms will become visible to you, even though, of course, they won't look like they're in focus because you're not focusing the point of your gaze is a little bit off to the side. Next slide. But when I started out, or no, this is a view I might get with my telescope. I have a 10-inch Schmidt-Cassegrain that I sometimes bring out to Woodridge Farm Brewery. And again, under dark skies, I'll get this. Next slide. But the first time I ever saw this galaxy was with a 6-inch Newtonian, which was my first quote unquote big telescope that I had in high school. And I saw no spiral arms at all. And yet, I was very pleased with myself. I was very happy because I found this thing. In those days, there was no go-to or anything. You had to star hop to your objects. You had to find your way around in the sky. And if you saw two nuclei and you realized, I found M51, that was a great sense of satisfaction. Next slide. Nowadays, we can do one more thing for visual. This is sort of a mashup of visual and digital imaging because it gives you some of the features that you can really capture oftentimes only with digital imaging, um, but you can see them live. So CAS has what's called a night vision monocular, a PVS 14, and it's also called an image intensifier. You stick this thing into the eyepiece, into the focusing tube of your telescope, and as Dave Sappington said earlier in the meeting, he brings this out whenever he comes out to Woodruard Brewery. And when you stick this into your telescope, it intensifies the light so that you can see all those faint features, like here's M51 through the night vision device, and you can see all those spiral arms. But again, you can tell this is nothing compared to that first image we saw, that Hubble Space Telescope image. So if you're getting into visual astronomy, one of your first lessons is going to be um, you have to be aware of what to expect, and don't expect a Hubble Space Telescope type image. Next slide, please. Oh, so here's another Hubble Space Telescope image. This is another nebula that was recently discussed in this meeting. In fact, it was the target of the month, according to Dave, which is the Orion Nebula. And what you see right there in the middle, just slightly above center, is that trapezium, those four stars that are very bright in the center of this nebula. Now look at this enormous amount of detail, and this is also very high magnification. This is the kind of thing that you might see on a website and you go, I want to see this. And you go out and you buy yourself a telescope. Next slide. And if you have like an enormous amount of money and you get yourself a very big telescope and you have digital imaging, then you might get an image like this. Here you see the same nebula. You see a lot of details there. You see some pretty colors. You see that trapezium of four stars. But this is not what you're going to get visually. This is still something that it requires a digital sensor and post-processing. Next slide to see that kind of thing. This is what you might get visually in a dark sky. This is what I would get using my 10-inch telescope. If I brought it out to Woodruard Brewery, I'll see something like this. It's quite nice. On the right there, you see I've zoomed in on the trapezium. What I like to do is look at the trapezium in very high power and identify, in fact, two extra stars that are right next to the four, the so-called stars E and F. They're very hard to see unless you have very dark skies and good seeing, and there's not too much turbulence. This is the kind of thing so this image, compared to what we first saw from the Hubble Space Telescope, of course, is not really comparable, but it's still a great pleasure to see some details like this. And some of this nebula detail, again, it requires averted vision to pick that up. Next slide. Oh, and here's a picture that Marshall Fainter sent me. This is M42, the Orion Nebula again, same object, but probably this is probably comparable to what might have been gotten in film, except for in film it likely would not have been in color. Next slide. And this is what you might see in a larger telescope than mine, such as a 20-inch or 22-inch telescope we have at Woodruard Brewery. You'll see more details and further away from the center of the nebula. Next slide. And this is what you might see in a small, typical, like my 6-inch Newtonian that I had when I was in high school. This image. I've taken all these, of course, all these sources are digital, but I've kind of modified them to look like what I remember seeing visually. Next slide. And again, with the night vision monocular, which Dave Sappington will bring down to any of our cast star parties, you can see a lot more detail. You can see a lot of the fainter nebulosity that's further away from the center of the nebula. Next slide. The other cool thing about the night vision device is you can use it without a telescope, and you can see things that there's no way you're going to see them with a telescope, no matter how big the telescope is. So there's a feature here on Orion called Barnard's Loop, which you see there. I've got my little animation going. Barnard's Loop is this long, very large object. It's almost the size of the whole Orion constellation. And it's so faint that if you use any kind of a telescope on that, you would you would not be able to see it. It's really only visible either through digital imaging or through an image intensifier like this. And keep in mind, this is a view through the image intensifier with no telescope. This is no power. It's like 1x power. You can see the Orion constellation there, and then you can see some of the nebulosity associated with it, like the Horsehead Nebula, and of course the Orion Nebula, which is the center of the sword. It's a very cool device, and make sure that next time you're out with Cass at some event, ask Dave to show you the image intensifier. Next slide. So here's another favorite object of mine, a globular cluster. This is the Great Globular Cluster in Hercules. This is probably a Hubble Space Telescope image, although I'm not entirely sure. Anyway, this is a state-of-the-art image, and it's the sort of thing that you're going to go, I want to see this through a telescope. Next slide. But you're going to have to reduce your expectations. So here's a digital capture, which is probably comparable to what you might see through the 20-inch, the big telescope that we have down at Woodward Brewery. Next slide. And if you use your own telescope, like in one of my telescopes, I might see something like this. Notice there's these two stars that I use as a reference. They make this long, wide triangle. I can't use my pointer now. Anyway, I've tried between all these views of the of this object, I've kept the orientation the same. You'll see that in just a second. Next slide. When I first looked at this object, on the left there, you see what I might see in a 6-inch aperture telescope. So that was my quote unquote big telescope when I was in high school. And in that telescope, I could just barely make out individual stars in the globular. Especially if I used a little bit of averted vision, then maybe I would see the individual stars, just kind of the hints of them. The first time I saw this, though, was with my first telescope, which was a 2-inch refractor. And on the right, you can see there I was just pleased to identify the object as not being a star. Because that's all you could do with the 2-inch aperture. There was no way to see individual stars in the globular cluster, but you could see it as a fuzzy spot. And that pleased me to no end back in the day. A far cry from what can be done now with digital means. Next slide. And again, if you use the image intensifier, it really brings out all those stars. So this is an image sent to me by a fellow in Rappahannock Club. Gosh, I always got a block on his name. I can't think of it right now. And he has a 16-inch Newtonian. So all these stars in this cluster, the cluster is like magnitude 6 or something. It's actually just barely naked eye if you know where to look. But all the individual stars are around 10 or 11 or 12 magnitude. So to really resolve them, you need a larger aperture, and of course they look very faint. But with the intensifier makes them a lot brighter, of course. It makes it very easy to see all those stars. This globular cluster has like 500,000 stars in it. So it's an impressive object to look at. Next slide, please. Now, I know I don't want to bore people, but I want to show you a few more objects real quick. The Ring Nebula on the left, another favorite object, very easy to find. Looks awesome in the Hubble. Nobody looks through the Hubble Space Telescope, but the images that telescope makes from orbit, of course, are amazing. And then on the right is sort of the image you might get looking through a typical medium-sized amateur telescope. One thing you will not see, not even through the 20-inch at Woodward Brewery, is you won't see that central star. I didn't take the trouble to erase it out of that digital image. You'll see that little ring, and it'll look a little bit like sort of like a bluish diamond, a donut, but you will not see the central star. Next slide. And another object that I really like is the Dumbbell Nebula. It's quite a bit larger than the Ring Nebula. It makes it somewhat fainter, but since you're looking at it with lower power, sometimes it's a better object for smaller telescopes. Again, on the left, sort of a state-of-the-art image that might inspire you to get into astronomy. And on the right is a unistellar is a EV scope image, and that's also sort of comparable to what you might get in my telescope, my amateur telescope. But in that telescope, you will not see color. You just won't see color because the human eye cannot detect color at these low level, in this low lighting. Next slide. So let's finish up with something else, something totally different. With all those prior objects, we're talking about how hard it is to see faint things and how modern technology has brought faint things, has made them so bright and so spectacular that there's this huge gap between what you might expect to see visually and what you actually will see visually. Um, with bright objects like the moon and planets, that gap is not so big. And in fact, I've had the experience with my telescopes trying to do some imaging of the moon and planets where I feel like, of course, this reflects badly on my ability as somebody who post-processes images. I feel like I still can actually do better visually than I can getting digital images. One of the things that will become very obvious when you look at bright objects is the so-called seeing. Seeing is the term of art that we astronomers use to describe the turbulence in the air. So if you're looking at the moon there on the upper left, you'll see the images kind of wobbling around a little bit. That is caused by turbulence in the air, in the atmosphere above our heads, the atmosphere through which the moonlight has to pass before it goes into your telescope. With the digital techniques, you can get rid of that. You have to take hundreds, if not thousands of frames, exposures, which is easy to do now with the digital cameras. You're basically shooting a video of what is being seen through the telescope. So on the right side, for example, I show a single frame on the upper right side, which is just one of hundreds or maybe even thousands of frames that were taken and then digitally stacked to produce that frame on the lower right-hand side of the moon, which you can see is visibly sharper. So that's one thing you can do digitally. But if you're looking visually at that same field of view, although the features won't always be that sharp, there will definitely be moments where the seeing might stabilize just for a moment, and you might see all the same details and all the same features that the digital camera can capture. Next slide. And finally, for bright objects, I would like to draw your attention to another visual tool that I really like, which is called a bino viewer. CAS recently acquired for the loaner program a so-called linear bino viewer. It looks just like in this picture. Ours is a different brand, so it has green collars and green sort of highlights on it. But it's basically exactly the same device. And the advantage here is, next slide, when you go to look at, let's say, the moon, especially if you're looking at high power, the higher power eyepiece you use on something like the moon, the smaller the so-called exit pupil is that your eyepiece produces, especially depending on the aperture of your telescope. And a small exit pupil just means that all the light coming into your eye is coming from a very tiny source to make that image on your retina. But because it's from such a tiny source, what happens is almost everybody has, especially as you get older, you have these things in your vitreous fluid inside your eye, little bits of debris that are floating around all the time. You don't see them normally during the day, but you see them if they're illuminated by a very small pinpoint source in front of your eye, which is what this eyepiece is going to be at high power. And these bits of debris cast shadows onto your retina. And these are called floaters. You see them all the time when you're looking into an eyepiece at high power at a bright object, a bright diffuse object like the moon. And they interfere with your vision. And sometimes there'll be a floater like right smack over top of your fovea. In other words, right over the middle of your center of your field of view. And, and you'll have to bob your eye around trying to get rid of the darn thing. And it keeps floating back into the center. And it'll just drive you crazy. But if you're using a bino viewer, next slide, Although you will then perceive floaters from both eyes, the floaters will never be the same in both eyes. And what this allows your mind's eye to do is to look past the floaters. What your right eye won't capture because there's a floater in the way, your left eye will capture because there won't be a floater in the way on that exact same part of the field of view. And it basically makes the floaters kind of disappear. So this is my promotion of the bino viewer. Is something if you like to observe visually, especially if you like to observe the moon, also the planets, um, you should borrow that bino viewer and check it out. Next slide. So in conclusion, for faint objects, if you're going to go with visual, don't expect too much. That's hard given all the imagery that's out there now that you see on the internet. It's very hard not to expect too much because you tend to expect a lot. Learn to use averted vision to see those faint details. And try out the Cast Night Vision widget at our next star party. And for bright objects, I just really recommend a bino viewer um, to ameliorate the effects of floaters when you're observing something like the moon. And that is the end of my show. Thank you.
Hey, Boris,
Yeah,
that was fantastic. I'm thinking if we could do this maybe 2 or 3 times a year at the on the Saturday thing for
yeah,
new members. I think for me, I've told you this before. I found it very frustrating when I brought a telescope home and I'm looking up and I'm trying to see these spectacular things, and all I'm seeing is a little faint fuzzy. So I think this was an exceptional way to get that information across, and I'd really appreciate it if you
right.
could do it, on a recurring basis. That'd be great.
I'd be pleased to.
Anybody got questions? Questions?
Yes, Daniel.
So not a question, but I'll highlight. Dave Sappington was pointing out. You were saying there was some name that you were forgetting from Richmond, and he says it Corey Dahlmeyer, I
That's
believe.
it. Corey Dalmar. Yeah, that's the guy. He said, in fact, Corey was the person that had first introduced Dave to the whole image intensifier technology. And Corey was the one that consulted with Dave on getting his own image intensifier and then consulted with the CAS, the club, to get the club image intensifier. So, yeah, he's been a great resource in that technology. Many thanks to Corey.
Any other
Nobody has
questions?
other questions. No questions. Richard,
So
what's your question?
hey, Boris, one other thing. So just to remind everybody on this image intensifier, Dave has one that he owns, and if
Yes.
you're out with Dave, he'll show you one. Dimitro has one, and he's also very kind and lets us,
Oh, so we have three now at
now
our
and the
disposal.
club owns one,
Yeah.
so we have 3 opportunities to use them,
Wow.
and they
Yeah.
really are pretty spectacular. So
Well, if you ever get two of them in the same place at the same time, which is not unlikely sometimes, um, we have also we had a session. There was a comet like a year ago when the club had first gotten its intensifier, and then we were using Dave's and the club's side by side like binoculars. And even though they're not even connected, it actually worked quite well because they are zero power, right? There's no
yeah,
magnification. And you could look in stereo at like the comet in the sky, and you could see all this detail, and you can look at all these things. It was amazing. It's really an amazing technology.
yeah, and also Dimitri has a note here. It says also you can use it with or without filters to compare. So with
Right,
filters you can see nebulosity and the like, and also
right.
so
So
we
that slide with the Orion constellation and Barnard's Loop and some of those nebulae, that would have been a view through a so-called H alpha filter, I believe,
yeah.
um, which darkens the rest of the sky and brings forth that nebulosity more. Yeah.
So, Boris, one other note for you is I'm watching the counts of the participants who've been on. Nobody left. Everybody stayed through and
Oh,
listened to you. So,
thank you
so,
very much,
so
folks.
good on
I
you.
appreciate it.
You bet.
I was afraid. I was afraid everyone was going to tear out of here.
No,
It's so
this
late.
is a great discussion. I love this one. And I want to say I'm always honored to be a member of a club that has astronomy luminaries like you three guys, Rich and yourself and Marshall. I love coming to these events. I love learning from you guys. I think everybody feels the same way. So truly honored to be in your presence. And it's why we have every once in a while we'll have a session where our speakers are our own experts. And so I appreciate it. Thanks very much to Richard and to Marshall and to you, Boris, for your efforts on this.